Hi, this video is going to take a look at how we use synthetic division to help us factor polynomials and also how to find x-intercepts, which are also called zeros, when we graph polynomial functions. So first of all, let's start with this polynomial function. Let's say that I'm asked to factor that. If I'm going to factor it and it's an x cubed, I'm going to get 3 linear factors. Now, how am I going to figure out? It's going to be a linear factor times a quadratic factor. I don't know what that's going to look like, but it might be x plus 2 times a quadratic. It could be x minus 3. We just don't know. So what we do is start trying some linear factors and see if they divide in there evenly. Let's try x plus 2. If I do synthetic division, I have 2, -1, -7, and a positive 6. I'm going to do synthetic division with x plus 2. That means I put a minus 2 here. So I bring the first term down and I multiply, add, multiply, add, multiply, and add. Okay, I got a remainder of 0. What that means is that if I divide x plus 2 into this polynomial, I get 2x squared minus 5x plus 3. That means this is going to be 2x squared minus 5x plus 3. Now if that's the case, then I can look at what I have left here and see if I can factor it, and if I can't factor it, I use the quadratic formula. So let's do that. When I factor this, I can see that I get x plus 2, and then when I do backwards FOIL on this, I get 2x plus 1, x minus 3. Okay, let's look at this problem. It says factor x to the 4th plus 5x cubed plus 5x squared minus 5x minus 6. Now, if I'm going to factor that, I'm going to divide by some binomials, x minus 1, x minus 2, x minus 3, x plus 4, x plus 6, whatever. When I divide by a 2 using synthetic division, what I'm really testing is to see if x minus 2 is a factor. Now if I put a 2 here, I don't get a remainder of 0, which means x minus 2 is not a factor. If 1 gives me a remainder of 0, that means x minus 1 is a factor. And in essence, looking at what I have here, I can factor this now. X minus 1 is a factor. And what I have left in my trinomial will be x to the 3rd plus 6x squared plus 11x plus 6. Okay, so now I've divided this in there and it went in evenly, so this is my remainder. Now I'm going to take this polynomial and I'm going to repeat the process to see if I can find another factor. Okay, now look at this. I have my x to the 4th polynomial. This is how it factored. Now, I'm going to take this part and I'm going to see if I can find another factor. So what I'm trying here is I'm seeing if x plus 2 will divide evenly into there. So if I'm testing x plus 2, I put a -2 here. And when I put a -2 here, I get a remainder of 0. That means I've got x plus 2 times the quantity x squared plus 4x plus 3. Okay, now this right here, this quantity right here is going to replace that polynomial right there. Okay, so this is what I had to start with. After I divided out the x minus 1, this is the polynomial that I had left. I took this polynomial and I divided it by x plus 2, and it gave me this. So now I took these two and substituted in for here, and I'm looking at x minus 1 times x plus 1 times this. Now, so x minus 1 is done, x plus 2 is done, And this I can use backwards FOIL. Now if I couldn't use backwards FOIL, I'd use the quadratic formula, but I can see that this one factors to x plus 1, x plus 3. So I've got 4 linear terms. I factored this polynomial and I got 4 linear terms. The place where we use synthetic division the most is when we're asked to graph a polynomial function, such as the one that's listed here. Now when we go to graph this, there are basically 5 things we need to do. We need to find the y-intercept by letting x equal 0. We find the zeros, which are the x-intercepts, by letting y equal 0 and factoring the polynomial. We need to find the right-hand behavior, which is to ask the question, what happens as x approaches infinity, which means it gets very large. We need to find the left-hand behavior, which is asking what happens as x gets closer and closer to negative infinity. And then the last thing would be to find at least one point on each side of every zero so that we can get the basic shape of the graph. So let's go through these steps, and you'll see that on step 2, that's where we're going to need to use our synthetic division so that we can factor this. Okay, here's the first step. To find the y-intercept, we let x be 0, and we solve. So when I put 0 in for x, I get all these turn into zeros, and I just get 6, which means my y-intercept is the point 0, 6. The next step in our process is for us to find the zeros, which are the x-intercepts, so we let y be 0. When I let y be 0, I get this polynomial, and this just needs to be factored. So what I'm going to do is I'm going to start doing synthetic division, and I'm going to start putting some numbers here. Let's say I put -1. I put my coefficients here. I bring my 1 down, I multiply, I get -1. Add, get -3. Multiply, get 3. Add and get -2. Multiply and get 2. Add and get 8. Okay, obviously this is not 0, but it does give us some helpful information, because in my XY table, anytime you put a number in here to test it for a 0 and it doesn't work, this is an awesome byproduct of that. It gives me a point. -1 is not a 0, but when I put -1 in, 8 is my y value. This is part of the remainder theorem that we can use as a byproduct of our synthetic division. Alright, so that did not work. Let's try another one. Alright, let's try 2 and see if that works. Bring my 1 down, I multiply, add, I get 0. Multiply, 0, add, I get -5. Multiply, I get -10, add and get -4. Okay, that is 2 is also not a 0. But I do have some information here, because if I put 2 in, I'm going to get a -4. Alright, let's try another one. Okay, let's try the number 1. I bring down my 1, then I multiply and add. Multiply and add. Multiply and add, and I get 0. Okay, so that means when I put the number 1 into that function, I get a 0. That also means that this is an x-intercept, which means I consider 1 a 0. Alright, what that means for our purposes is, so far I know that if 1 is a 0, it came from the factor x minus 1. And then if I look at this, it tells me the quadratic that's left. 1x squared minus 1x minus 6. Now, the x minus 1 is done. I'm hoping being that I can factor this. I think I can. X and x, two numbers that multiply to give me negative 6, add to give me negative 1 would be negative 3 and a positive 2. Alright, from that I get my zeros, 1, 3, and negative 2. Now that also means over here I have the point 3, 0 and negative 2, 0 to go along with the other points that I have in my table. Okay, so let's look at number 3. Alright, I can actually do numbers 3 and 4 together, because what I want to do is just think through what happens as x gets really large or really negative. So when I get out to like 1 billion, I'm going to get a very large number here, and if I put in a positive billion and cube it, I'm going to get a really large positive number. So what that means is as x approaches infinity, my graph, my f at x, or you can call it y, y is going to approach infinity, which means it's going to go up and to the right. My graph is going to do this on the right end of its graph. Alright, when I look at the left-hand behavior, what I'm asking is what happens as x approaches negative infinity? What if you put like negative 1 million in here? If you cube negative 1 million, you get a very large negative number. So as x gets really large in the negative sense, y also gets very large in the negative sense. So it's going to go down and to the left. Which means the left-hand behavior is going to look like this. Alright, so the last thing we need to do is get a few points so that we see what our picture is going to look like. Alright, I have my graph here, and I've put on a few of my points. I put on the 3 zeros and my y-intercept. Now I need to put a point between all of my zeros. So I'm going to start with negative 3 because that would be over here. Now I could put negative 3 in there and cube it and square it times negative 2 and all that, but actually the synthetic division is a really slick way to get your table filled in quickly. So put a 1 there, multiply, get negative 3, add, get negative 5. Multiply, get 15, add, and get 10. Multiply, get negative 30, add, and get negative 24. That means this is negative 24. Alright, let's try another number. Alright, I'm going to try 4 in here and see what happens. I put a 1, multiply and get 4, add and get 2, multiply and get 8, add and get 3, multiply and get 12, and get 18. That means when I put 4 into my equation, I get 18 out. Now that lines up with what I already know, because I know that when I'm out here at the negatives, I should be way down here, going to the left, and as I get out to the positives, I should be going up and to the right. So let's plot those points and see what our graph looks like. Alright, as you can see, when I put my zeros on, and then I put my y-intercept, and I get a few other points, and then I also consider what happens as x gets really large, and as x gets really large in the negative sense, I get a nice smooth curve.